In 1985, Rick Cohn, also known as Richard Cohn, who teaches currently music theory at Yale University, discovered a device that's called transpositional combination. And it basically is something that happens with chords that have inversional symmetry. It's really actually much easier than the book shows you what's going on. But let's go with the very first one, Bartok's X cell. So Bartok's X cell is this part of transpositional combination. And Rick Cohn calls it really TC, the same way that he calls inversional symmetry IS. In either case, we have, for example, the very first one. For this to properly happen, you have to have a chord that's divisible by 2 is, I guess, the main thing. And it has to be inversionally symmetrical, otherwise it doesn't work. Let's do the very first one. Here's Bartok's X cell. Bartok's X cell. You were wondering all along, since we talked about the Bartok's Z cell all semester, whether or not there was Bartok's X cell. And in fact, there is a Bartok's X cell. It's a term that was created by Pearl and Antokolets, which Elliot Antokolets was one of Ludek's teachers, just to keep that in mind. Either way, here's the X cell. The X cell is 0, 1, 2, 3. And so what's going on with this? Well, let's convert it into a pitch class collection. So we were actually talking about something. 0, 1, 2, 3. Or if you want to absolutely write it in pitches, that's fine too. C, D flat, D, and E flat also works. I'm going to write it out right here. So we have C, D flat, D, and E flat. And that sounds like this. If you look at it really closely, you will realize that we have a half step and we have another half step. And then if we look on top, we notice that this dyad has been transposed by T2. So in transpositional combination notation that Strauss suggests, even though it has the flaw that if we're looking at bigger sets, it doesn't really work, but it only works for tetrachords. We then call this one a 1 asterisk 2. So basically the 2 means it's a minor second transposed by T2. And that's all that's happening. So here, this is the minor second. And this right here is a transposed by 2. What other things do we have? Well, on page 126, he lists all of them, but let's look at the fun ones. For example, there's also Bartok's Y cell. So let's look at Bartok's Y cell. Bartok's Y cell, and that's a slightly different beast. It is a 0246. And if we write it out as in pitches, oh, let's transpose this one to something else so it's not so boring. Let's transpose it up to D. So we're going to do D2, and we convert it to 0246. And so then we actually have our pitch class collection, which then will be 2, 4, 6, 8. You can already see how this is working. So here we have a D, we have an E, we have an F sharp, we have an 8. So immediately you say, well, yes, we have transpositional combination here as well. And it's easy to see how. The first one right here is 2. And from 2 to 4 is 2, so in that dyad. And then in this dyad, we have also 2. And they are transposed, so these are together, and then those are transposed by T4, because from 2 to 6 is 4, so T4. And so this is T4. And that's a transpositional combination. You can also write this one out as a 2 times 4, or 2 asterisk 4. 2 asterisk 4. And that's how you would describe this one. We could do another one. Let's do the Z cell. So we have all the cells together, so to say. So now we have the X, Y, and Z cells. And again, George Pearl coined that term, which was then adopted by Elliot Antokolets, who happens to be Ludek's teacher. One of Ludek's teachers is UT. So a Z cell, as you know, I now hear the crowds going 0167, and that is absolutely correct. We have a Z cell 0167. And if you look in the book, it says that it has 1 asterisk 6 and 5 asterisk 6 as well. And the reason why that works is the following. I'm going to write it super tight together. So we'll do this one as is. And we have a D flat right here. And then we have 6 and 7. So that means our first is 1, because that's a minor second. And right here, this is 1 as well. How far are they spaced apart? Well, I will just go from 0 to 6, and I realize that they're at T6. So right here is T6. So here, my abbreviation really will be 1 asterisk 6, right? But then it says there is also 5 asterisk 6. And how does that work? Well, it's actually pretty easy. All we have to do is from G to C, which now is 5, because a perfect fourth is always 5, just to add to the confusion. And the next one then will be D flat. And now we can see these are also spaced apart by 5. And in the middle, we again have T6, which then gives us the second notation for this one, which will be 5 asterisk 6. And that's how transpositional combination works. Here are the different cells that Bartok put together. Please know those cells. You should know what Bartok's X cell, Y cell, and Z cell is. We also can have transpositional combination with any kind of set class that's divisible by 2. We can also have it with a hexachord, or we can have it with an octachord, or anything that's divided by 2. So let's pick one. We can go to page 111 under the inversional symmetry chart and pick one of those hexachords. So I'm just going to pick 6, 7, and that's 0, 1, 2, 6, 7, 8. I'll convert it to some pitches. So a pitch class set. So it's 0, 1, 2, 6, 7, 8. And since we're musicians, let's say C, C sharp, D, and F sharp, G, and G sharp. Okay, let's write it out. C, C sharp, D, and F sharp, G, and G sharp. Okay, so how is it divisible? Well, you can see it right away. If you look at the numbers, it's the easiest way to find. We have 012, so it consists of set class 012. And then it also consists of set class 012 again, right here, because 6, 7, 8 is, of course, 012 as well. And these are transposed by T6. We have 012 right here, 012 right here. Those are set classes 012. Or to say it in the right lingo, let's say 012 belonging to set class 012 and 6, 7, 8 belonging to set class 012 are transformed through a transposition by tritone. So and then this is obviously T6. If you wanted to, you could also write it out like this: 012 asterisk T6. Can we also have it with a different chord? Yes, we can have an octachord. Here's a very famous octachord belonging to set class 828. And this particular octachord is known as the octatonic scale, or mode 2 in Messiaen's modes of limited transposition. 0, 3, 4, 6, 7, 9, 10. Let's convert that into a pitch class set. So we have 0, 1, 3, 4, 6, 7, 9, 10. we have O, 1, 3, 4, 6, 7, 9, 10. And let's listen to it real fast. Okay, just cool sounding scale. And let's divide it up. The first division that's really obvious is 0134, and that belongs to set class 0134. And 0134 in itself, of course, is a transpositional combination, because if we look at it, it's 0134. So we have minus second and a minus second, which is 1. And this is a 1 asterisk 3. Now, if we go larger, then we will also find that 6, 7, 9, 10 is also 0134. And here we are, just go minus 6. So we have 0, 1, 3, and 4 right here. So we have this cluster right here, and this one right here. And those are connected by T6 as well. So we have T6 right here. Now, and that's also audible. If you listen to it right now, here we go. Or clearly hearable. In our notation, we could say, okay, well, this one is 0134 asterisk 6. You know, I need to see this mistake right here. I should have just written 6. I know it's T6, but you just write it like that. Okay, now the other way here is recognizing that the octatonic scale also is a combination of 2 Z cells. So how does that work? Well, we have, remember that the Z cell is 0167. So we have 0167 right here. That's 1. And then we have another one right here, right here. And that's the other 0167. We can double check on that, of course, if you wish. So we have pitch class set 0167, and the other pitch class set would be 3, 4, 9, 10. We'll do 3 right here, which is really plus 12. So if we just subtract 3, really, then what do we get? We get 0, 1, 6, 7 again. So that also belongs to set class 0167. That means that now we have also this situation happening where we can say, oh, we have 0167, and here the transposition is T3. Okay, so then we can also write this out in the following way by saying 0167 asterisk 3. And that gives us Messiaen's second mode of limited transposition. You can also practice this with, for example, his mode 4, if you wish, or his mode 6, or mode 1, and it will all work out in a similar fashion. The last question that could arise right here, of course, is the inversional symmetry in the octatonic scale with the Z cell also audible? And I would argue that the answer is yes, because if we take the octatonic scale and we go right here, that's our first Z cell, and then the other Z cell that's at T3 is this one. Yep, it's very clear that here we're just dealing with a transpositional combination.